students. Today we will learn about the what is a clutch. So first of all, clutch is a device used to engage and disengage two coaxial shafts while at rest or in relative motion gradually. So there are two shafts which have to engage and disengage while at rest, and these shafts are coaxial. So coaxial means they have similar axis. So they have to engage and disengage while at rest or in relative motion gradually, and this is brought about with the help of a device which is called as the clutch. So clutch is a device used to engage and disengage coaxial shafts while at rest or relative motion gradually. So the gradual engagement of driven shaft limits torque demanded from the driving shaft. So those two shafts, coaxial shafts, one is the driving shaft and the other is the driven shaft. So the coaxial shafts, when the driven shaft engages, then it will limit the torque which is demanded from the driving shaft. Gradual engagement of driven shaft limits torque demanded from the driving shaft. So what are the requirements of a clutch? So a good clutch should fulfill the following requirements. So what are they? Good clutch should fulfill the following requirements. So what are they? The force required to disengage should be as minimum as possible. So the force which we are applying to disengage the shafts must be as minimum as possible. Then the operation of engaging should be possible at any speed of the driving shaft. So the operation of engaging should be possible at any speed of the driving shaft. Should be possible at any speed. The heat generated during engaging should be minimum. So heat will be generated during engaging. So this heat must be the engaging mechanism should not rupture or introduce stresses in the clutch material. So when we are engaging, the engaging mechanism should not rupture or introduce stresses in the clutch material. Need for clutch. What is the need for this clutch in the automobile? So clutch is needed to transmit power smoothly. Transmit power smoothly. Then once the the clutch is engaged, must transmit power without slipping. So once the clutch is engaged, must transmit power. Then to overcome self inertia of the vehicle. So if clutch is not provided, then the vehicle will not overcome the self inertia. For gradual engagement of rotary motion from engine to the gearbox shaft. So for gradual, so not all of a sudden, but gradual engagement of rotary motion from engine to the gearbox shaft. So these clutches are also used to disengage drive from engine to gearbox for changing of different gears. So when you want to change the gear, you have to first press the clutch, then you will change the gear. So that is the meaning of this sentence. So they are also used to disengage drive from the engine to gearbox for changing different gears. At the time of stopping the vehicle, the clutch is utilized to disengage engine from the drive wheels and enable smooth stopping of the vehicle. So when you stop the vehicle, then this clutch is used to disengage the engine from the drive wheels. So clutch also takes care of the speed and torque fluctuation for engine crankshaft to gearbox input shaft, since clutch is made from friction material. So the clutch will also take care of the speed and torque fluctuations from engine crankshaft to gearbox input shaft. So from the crankshaft to the gearbox input shaft, what are the fluctuations that are taking place in the speed and the torque are taken care by the clutch, because this clutch is made up of friction material. So what is the classification of the clutch? How the clutch is classified? So clutches are of two types, that is positive clutch and gradual engagement clutch. Dog clutch or spine clutch. Then this gradual engagement clutch is of two types, that is friction clutch and fluid clutch or fluid flywheel. Then friction clutches are of many types, that is of four types, that is the cone clutch, then there is the disc or plate clutch, then there is semi centrifugal clutch, then the last one is the fully centrifugal clutch. This cone clutch is of two types again. So internal cone and external Then the disc or plate clutch is of two types, that is single plate clutch and multi plate clutch. Then multi plate clutch is of two types again, that is the dry clutch and wet clutch. So this is the classification of the clutches. So positive clutch. So simply we can say that these clutches are classified as positive clutch and friction clutch. So we will discuss in detail about this positive clutch one type and the friction clutch. So even a single plate clutch is also a friction clutch because it is a disc or plate type clutch, and cone clutch is also a friction clutch. So we are going to discuss now about the positive clutch, and among friction clutch we will study about single plate clutch, multi plate clutch, cone clutch and centrifugal clutch. So the configuration of the positive clutch is shown in the figure here. So you can see there is a driving shaft and this is the hub and there are jaws here. This is a component or a member A and this is member B, which is marked here, and there is this is the driven shaft on which the member B is fixed. So this is the driven shaft. Okay. So now we can see from this figure that member A is fixed to the driving shaft. So here this member A is fixed to the driving shaft and member B is fixed to the driven shaft. So this is the member B which is fixed to the driven shaft. There are two members, that is A and B. Member A is fixed to the driving shaft and member B is fixed to the driven shaft. So this member B is splinched such that it can move axially by shifting device that engages it by means of square groove in the flange. So here this member B is splinched in such a way that it can move axially. So it can move about the axis by a shifting device. So you cannot see, but there is a shifting device present here in the member B. This shifting device will engage it by means of a square groove in the flange. So you can see there is a groove here. Okay. So this is square groove and there are jaws provided on this inside the member B. The member B is flinched such that it can move axially. So it can move about the axial direction or by on the axis by a shifting device that engages it by means of of a square groove. So here there is a square groove in the flange. Okay. So once engaged, the whole system rotates as a solid mass. So when once the driven shaft and the driving shaft are engaged, this whole system will rotate as a solid mass. Once engaged, the whole system rotates as a solid mass. So this is used when power is transmitted continuously and without slip. So this type of clutch has to be used when the power is transmitted continuously and without slip. So such kind of drives are used for transmitting power from electric motor to ball mills and pumps, etc. So example for this kind of clutches is, so such drives is used for transmitting power from electric motor to ball mills, pumps, etc. So here the transmission of power is continuous without any slip. So that is why it is used in transmitting power from electric motors to ball mills and pumps, but not in automobiles. The next kind of clutch is the friction clutch. So these clutches are used for engaging and disengaging the driving shaft from the driven shaft from the driving shaft very frequently. So here there is no continuous transfer of power. There will be engaging and disengaging of the driven shaft from the driving shaft frequently, now and then. So these friction clutches are extensively used in automobile industries. So these clutches are used for engaging and disengaging the driven shaft from the driving shaft frequently. So frequently, okay, not continuously. So these are used in automobile industry extensively. Now we have already discussed different types of friction clutches. We are going to discuss a few of them. So different types of friction clutches. So the first one is the single plate clutch. So the single plate clutch consists of two flanges with friction lining on one flange, which is mounted on the driven shaft. So there are two flanges. So here you can see this is the driving flange. Okay, this one. and this is the driven flange. So it has two flanges and there is a friction lining on the driven flange. So in this system, one flange is rigidly keyed to the driving shaft and the other is free to move along the splines provided on the driven shaft. So there are two flanges, one is the driving flange and the other is the driven flange, and the flange which is present on the driving shaft, so this flange is keyed rigidly, so this flange cannot move about, but the driven flange which has friction lining on it can move freely along the splines which are provided on the driven shaft. So here it consists of two flanges with friction lining on the flange which is mounted on the driven shaft. So one flange is rigidly keyed to the driving shaft and the other is free to move along the splines provided on the driven shaft. So during normal working condition, that is when the driving shaft is also rotating, the clutch remains in engage condition. So during normal conditions is when the driven shaft is also rotating, the clutch remains in engage condition. So in this condition, the required force, that is F, is provided by a spring which forces the driven shaft to move towards the driving flange to make contact between two friction plates. So during this condition, what happens is there is force applied and this force provided by a spring. Okay, the spring is not shown in this figure. This force is provided by the spring which will force the driven flange. So here this is the driven flange to move towards the driving flange so that it will make contact between the two friction plates. So the torque is transmitted by means of the friction force between the two plates. So when these plates of the flanges, so here there is a friction plate, when they come in contact with each other, then the torque is transmitted by means of the friction force between these two plates. So in this case, that is when the normal conditions, when the driving shaft is rotating, then what happens is the force, that is the required force F, is provided by means of a spring which forces the driven flange to make contact. So it will force this driven flange to move towards this direction and make contact with the driving flange, and the two friction plates come in contact. So here there is a friction plate lining, and that because of this friction plate the torque is transmitted by means of frictional forces between the two plates. So when this is not required, okay, when we require disengagement, not the engagement of the plates or shafts, then what we do is when it is required to disengage the driven shaft, the coaxial force is released and the driven shaft moves along the axis and the friction plates are separated. So what happens? When the disengagement of the two shafts is required, then we will release this force. We will not apply the force. Then this driven shaft moves along the axis in this direction and these two plates get separated and the friction force which was being produced will stop, and this will cause the disengagement of the shaft with the help of this clutch. So this type of system is universally used in automobiles. So when it is required to disengage the driven shaft, the axial force F is released and the driven shaft moves along the axis and the friction plates are separated. So this causes disengagement of the two shafts. That is the single plate clutch is used universally in automobiles. So this is about the single plate clutch. So we have discussed about single plate friction clutch. Now we will discuss multiple or multi-plate clutch. So the configuration of this multi-plate clutch is shown in this figure. So in this system, the number of plates used are more than 2. So usually 4 to 6 plates are used. So the working of this is similar to single plate clutch, except that the torque transmitted to the driven shaft is much higher compared with the single plate. Why? Because the surface area in multi-plate is higher. That is why the torque which is transmitted to the driven shaft will be more in the multi-plate clutch when compared to that of the single plate clutch. So here in this system, the number of plates used are more than, here you can see that these are the plates. There is friction lining on either side of the plate. So we have shown just two plates here, but usually there will be more than two plates. That is 4 to 8 plates are usually present. So working is similar to single plate clutch, except that the torque transmitted higher than the single torque transmission is higher because the surface area of multi-plate is much higher. So, as the torque transmission to the driven shaft is higher, even the power transmitting capacity is much higher than single plate for the same size. So, power transmission capacity is much higher single plate for the same size also. For the same size. So all the clutch plates are dipped in the oil bath to dissipate the heat quickly as the heat generated is larger. So another difference is that the plates are dipped in oil bath, dissipate heat as the heat generated is higher in multi-plate clutch. So this type of clutch is usually used or most commonly used in two-wheelers as it is more compact. So that means it is small in size. So the system used, that is mounted on the engine shaft, also acts as a flywheel in two-wheelers. So this system also acts as a flywheel in two-wheelers. So from the figure we have seen that in single plate clutch we had only one plate and there was friction lining present on the plate. But here there are multiple plates. This is the engine shaft, that is the driving shaft, and this is the driven shaft. So these plates are mounted on the driven shaft and springs are provided for this driven shaft to move closer to the driving shaft or away from the driving shaft, as we have discussed in the single plate clutch. So the working is similar to that of single plate clutch, but the only difference here is there are more plates provided with the friction lining on each plate, and the torque which is transmitted to the driven shaft is more when compared to that of single clutch. Because the torque is more, even power transmission capacity is more for multi-plate clutch. So as the power transmission capacity is more heat will be generated. So to dissipate this heat, these plates are dipped in a oil bath so as to dissipate the heat. So this is all about the multi-plate clutch. The next type of clutch is cone clutch. That is a friction clutch. So the operation of this cone clutch is similar to single plate friction clutch, except that the engaging flanks are made confirmed. So here we can see that there is a single member for the two flanges. Okay, these are the flanges. You can see there is a driven flange and there is a driving flange here, or it is called as the driver flange. So it is made conform, unlike in the single plate clutch where it was made as separate members. The operation of this clutch is similar to single plate clutch, except the engaging flanges conform. So as we can see in the figure, they are made conform. The driven member resting on the feather key in the driving shaft can be shifted along the shaft by a forked lever A. So here we can see there is a lever A. So the driven member, that is this member, this portion which is resting on the feather key. Okay, it is resting on a feather key in the driven shaft. So this is the driven shaft. So this driven member is resting on a feather key on the driven shaft. So it can be shifted along the shaft by a forked lever A. So this driven member can be shifted along this shaft, that is on the driven shaft, by this forked member A, forked lever A. So for bringing the frictional surfaces in contact. So you can move this driven member in this direction with the help of this lever A to bring the frictional surfaces in contact. So here you can see this is the conical frictional surface. To bring that in contact, this lever A is helpful. The driven member resting on the feather key in the driven shaft can be shifted along the shaft by a forked lever A for bringing the frictional surfaces in contact. The torque is transmitted from the driving shaft to the driven shaft due to the frictional resistance set up at the contact surface. So here frictional resistance is set up at this contact surface. Because of this frictional resistance, torque is transmitted from the driving shaft to the driven shaft. So this is the driving shaft. So torque is transmitted from this shaft to this shaft because of friction which is caused at the contact surfaces. So here, due to friction resistance set up at contact. So the spring which is shown in this figure keeps the clutch faces in contact by providing the required force. So this spring will give the required force, so this force to keep these two surfaces, that is the driven member and the driving member, in contact with each other. The spring keeps the clutch faces in contact, providing required. The cone angle, so here you can see this is a conical frictional surface. The cone angle which is provided lies between 10 to 15 depending upon the frictional material selected. If the frictional factor of the material is high, it will require less conical angle. So if the frictional material which you are using has low frictional capacity or frictional factor, then the cone must have a larger angle. Cone angle provided lies between 10 to 15. That is 10 degrees to 15 degrees angle will be there depending on the type of frictional material selected. Higher frictional material or higher frictional factor requires less cone angle. So this type of clutch will give better contact when compared to single plate because of the inclined surface. That is because of the conical angle which we have provided here, it will give better contact when compared to the single plate. Better contact compared with single plane plate because of inclined surface. So this clutch, that is the conical clutch or cone clutch, is simple in construction and easy to disengage. Simple in construction and easy to disengage. So, but presently this type of clutch is rarely used because its exposure to dust will tend to bind the two cones rigidly and it will become difficult to disengage them. So, if this type of cone, when it is exposed to this type of clutch, when it is exposed to dust, then it will bind the two cones or two parts, that is the driven member and the driving member together. Then it will become difficult to disengage them. Rarely used as its exposure to dust tends to bind the two cones rigidly and becomes difficult to disengage. Now we will discuss the centrifugal clutch. So the configuration of this clutch is that it consists of number of shoes on the inside of a rim of a pulley. So here you can see there are shoes present here and there is spider. Okay, so all these black colored part are the shoes. Okay, so there are number of shoes on the inside of the rim of the pulley. So you can see if this is the rim of the pulley, so inside this there are number of shoes provided. The outer surface of the shoes are provided with a layer of frictional material. So if this is the shoe, the outer surface is covered with a black material and this material is nothing but the frictional material. Configuration is it consists of number of shoes on the inside of a rim of pulley. The outer surface of the shoe is lined with a layer of frictional material. So these shoes are held against the spider as shown in the figure on the driving shaft by means of springs. So here you can see springs are provided inside the shoes and these shoes are held against the spider. So you can see this is the spider and this is the shoe. So they are held against the spider with the help of springs on the driving shaft. Okay, so they are present on the driving shaft. So here you can see these are the spiders and shoes are held against these spiders with the help of springs. So here you can see the frictional lining, and this is the shoe, and this is the outer cover plate, and this is the driving shaft, and this is the driven shaft. So this centrifugal clutch setting, that is the rim inside the pulley which has the shoes and the spider setup, is present in the driving shaft of the clutch. So these shoes are held against the spider on the driving shaft by means of springs. So during revolving the driving shaft, the weight of the shoe sets up centrifugal force. So when the driving shaft rotates or revolves, what happens? The weight of this shoe, you can see the shoe setup is quite heavy and it has the frictional lining, and this shoe, because of its weight, will create the centrifugal force during revolving of the driving shaft. The weight of the shoe sets up centrifugal force. So when the centrifugal force is less than the spring force, then the clutch is not engaged. So here there are two forces acting on the shaft. So there is the centrifugal force and the spring force. So when the spring force is, that is the centrifugal force, is less than the spring force, then the clutch is not engaged. When the shoe, or that is the centrifugal force, is less than the spring force, then the clutch is not engaged. And so when it is not engaged, the driven shaft will not get any torque, and the driven shaft will not get any torque. Okay. So, but when the centrifugal force is more than, or when it exceeds the spring force, then the shoe moves outward and comes in contact with the driving member and pressed against it, and the driven shaft starts rotating. So what happens when the centrifugal force is more than the spring force? Then this shoe will start moving outward, that is towards the driving member, that is the driven member. It will come in contact with the driven member, it will get pressed against this driven member, and the driven shaft will start rotating, that is this shaft will start rotating. When does it happen? It happens when the centrifugal force is more than the spring force. Only then the shoe will come out, it will come in contact with the driven member. Okay, it will press against its surface, and then the driven shaft will start rotating. When the centrifugal force exceeds the spring force, the shoe moves outward and comes in contact with the driven member and gets pressed against it, and driven shaft starts rotating. So this is very much successful in Luna, which was easy to operate. So This type of clutch is successful in Luna. Successfully used in Luna, which is easy to operate. So some minimum speed of driven shaft is required to engage the clutch and start the vehicle. So some minimum speed of driving shaft, so which can be changed by an accelerator. So this speed which can be changed by the accelerator is required to engage the clutch and start the vehicle. So this is all about different types of clutches. So we got to know what is a clutch, what are the needs for the clutch, classification of the clutch, then different types of clutch, that is positive clutch and friction clutch. In friction clutches we have seen four different types of clutches. So I hope you have understood the topic. Thank you.